Hey everyone, welcome back to another video by Camroom 5. In today's video we're going to be solving some questions from the MCQ papers for mole and stoichiometry, and we'll try to see how to polish our concepts for quicker responses to these questions. One of the questions says most modern cars are fitted with airbags. These work by decomposing sodium azide into to liberate nitrogen gas, which inflates the bag. A typical driver's airbag contains 50 grams of sodium azide. So what happens is you have the mass of sodium azide. So mole of sodium azide is equals to 50 gram divided by the molecular mass. Molecular mass is going to be 23 plus 14 times 3. So 14 times 3 plus 23, 65. And when you divide it by 65, the moles turn out to be 0.769. So 0.769 is the mole. Now they're concerned about the volume of nitrogen. 2 mole release 3 mole of nitrogen gas. So you divide it by 2 times 3, you get number of moles of nitrogen gas, which is mole of nitrogen is equals to 1.153. When you're trying to find out the volume in decimeter cube, you times 24, so 27.69. So 27.69 is C is the right answer. Let's look at this question which I have over here. On collision, airbags in cars inflate rapidly due to the production of nitrogen. The nitrogen is formed according to the following equations. How many moles of nitrogen gas are produced from 1 mole of sodium azide? So now you can see your equation has 2 moles producing 3 moles. I would convert it into 1 mole because the question is concerned with 1 mole. So 1 mole would produce 1.5 mole. So one thing is for sure, the answer of nitrogen is going to be 1.5 or more. But if you notice clearly, sodium azide also makes sodium, which later makes more nitrogen gas. So you can see 2 sodium azides make 2 sodiums, and then 10 sodiums make 1 nitrogen. So notice clearly, if 2 mole of sodium azide give you 2 sodium, 1 would give you 1. And in a very similar way, if 10 sodiums give you 1 nitrogen, then 1 would give you 0.1 nitrogen. So using the second equation, I also found out that 1 mole sodium azide can also give you additional 0.1 moles. So nitrogen total mole is equals to 1.5 from equation 1 and 0.1 mole from equation number 2. So the final answer is going to be 1.6 moles total nitrogen. Let's do more questions of this sort, like this question. The petrol additive tetraethyl lead is now banned in many countries. When it is completely burned in air, lead oxide, carbon dioxide and water are formed. How many moles of oxygen are required to burn 1 mole of tetraethyl lead? So you can see Pb C2H5 times 4 plus oxygen gives you, how many carbons are here? 2 times 4. So you got 8 carbons. So 8 carbon dioxide. How many waters can be made? So 5 times 4 is 20. So you get 10 waters because 20 hydrogens can give you 10 waters. And you're also getting lead oxide, right? So you also get lead oxide PbO because there's a simple lead, 1 lead, so 1 lead oxide. Let's count the number of total oxygens needed. So for example, I have 8 times 2, which is 16, 10 times 1, which is 10, and a single 1, so plus 1. So it's going to be 16 plus 10 plus 1, 26, 27, 27 over 2, because oxygen is available as diatomic. So you need 13.5 mole of oxygen gas. Let's look at this question. It is more from redox. Chlorine dioxide is produced on a large scale as it is used for bleaching paper pulp. It is made by the following reaction. How do the oxidation numbers of chlorine and sulfur change in this reaction? So let's look at the individual oxidation numbers. On the left hand side, when you look at chlorine, there are 3 oxygens, which means -6, and a single chlorine. The total number is -1 because there's a charge of -1. So chlorine has to be +5 on the left hand side, so that with 3 oxygens it can give you a -1 total charge. So chlorine is +5 on the left hand side And when you look on the right hand side, there are two oxygens, so -4. Chlorine has to be +4. So chlorine is changing from +5 to chlorine +4, which means a change of 1 unit. Change is equals to 1 unit, or you can say 1 unit decrease. When I look at the options, my options could be either A for apple or B for berries. I'm going to go for sulfur also. When I look at sulfur dioxide involves two oxygens, so -4 because of oxygen. Sulfur has to be +4. On the right hand side, when I notice sulfur, it is sulfate. Sulfate is always +6 for sulfur. So here sulfur is +6. So sulfur is changing from +4 to sulfur +6, which is a change of 2 units. So I can notice sulfur is changing by 2 and chlorine is changing by 1. So my answer is going to be B for berries. Let's look at more questions. A sample of chlorine containing isotopes of mass number 35 and 37 was analyzed in a mass spectrometer. How many peaks corresponding to chlorine ion were recorded? So you can have three different sorts of chlorine. Let me show you. Either both with a mass of 35 or one with 35 and one atom of 37. So that is another ion. Or the third one is going to be two chlorine atoms both having a mass of 37. These are the possibilities. So I can have three different masses of chlorine recorded here. This question I really liked. The amount of calcium ions in a sample of natural water can be determined by using an ion exchange column as shown in the diagram. You're adding your sample from the top, there's ion exchange. A 50 centimeter cube sample of water containing dissolved calcium sulfate was passed through the ion exchange resin. Each calcium ion in the sample was exchanged for two hydrogen ions. So it's important to notice that each calcium is replaced with double hydrogen ions. The resulting acid solution collected in the flask required 25 centimeter cube of 1 exponent -2, if I'm not wrong, -2 mole per dm cube potassium hydroxide for complete neutralization. What's the concentration of calcium sulfate? So we need to look at the idea that moles of potassium hydroxide is equals to 25 times 1 exponent -2 divided by 1000. This will give you the moles of potassium hydroxide to 25 times 1 exponent -2 divided by 1000. So that's 0.00025 mole of potassium hydroxide. The same amount is for hydrogen ions because they have a ratio of same. So hydrogen ions were also required same moles. Now you can notice that calcium and hydrogen ions have a ratio of 2:1. So 0.00025 will be equivalent to half of it because calcium is literally half. So it's going to be 0.000125. This is the moles of calcium. Now notice that actually the sample had 50 centimeter cube of sample. So concentration is equals to moles divided by volume. How much moles you have? You have 0.000125. That is 50 centimeter cube, but that's centimeter cube. So divided by 1000 extra. And that will give you the concentration. So divided by 50 times 1000, 0.0025. So that's going to be 2.5 exponent -3. Yes, that's A for apple is the right answer. Let's look at more questions. I really like this question also. In an experiment, 50 centimeter cube of 0.10 mole per decimeter cube solution of a metallic metal reacted exactly with 25 centimeter cube of 0.10 mole per dm cube aqueous sodium sulfite. You can see the equation involves sodium sulfite is changing into sulfate. So sulfite is changing into sulfate. If the original oxidation number of the metal in the salt was plus 3, what would be the new oxidation number of the metal? Here, a very important idea is involved, and that idea is that change in oxidation number is proportional to the change of mole ratios. So let's talk about it. We need to focus on this on a deeper level. Let's see. If you notice the moles of sulfite ions, you can find out the fact that it was 25 centimeter cube times 0.10 mole per dm cube divided by 1000. So the moles of sulfite is equals to 25 times 0.1 divided by 1000. That's 0, literally that's 2.5 exponent minus 3 moles. How much metal was required? So when you notice the moles of metal, I don't know what oxidation state it is, but that's going to be 50 times 0.1 divided by 1000. My answer is going to be 5.0 exponent minus 3 mole. You need to take the mole ratios here. So the mole ratio between metal and sulfite, it is 5 exponent minus 3 and 2.5 exponent minus 3. It turns out to be 2:1. So 2 moles of metal were needed and 1 mole of sulfite. Now what's important? If the mole ratio of metal is double and the mole ratio of sulfite is 1 times, the 1 actually comes from the change in oxidation number of metal, and the 2 actually comes from the change in oxidation number of sulfite. So actually the change in oxidation number of metal is 1 and the change in oxidation number of sulfite is 2. We are concerned with the change in oxidation number of metal. It is 1 unit. The beginning was 3. The ending should be either 2 or 4. Now how do we pick? Focus on the fact that the oxidation number of sulfur is increasing. Sulfur is changing from plus 4 in sulfite to plus 6. It is increasing. So metal should be decreasing because two elements can't increase their oxidation number at the same time. So what happens is the metal oxidation number should decrease. So it goes from plus 3 to plus 2. I would really recommend you guys watching this portion of the MCQ part again if you had even the slightest doubt. Moving on. Let's see. Yeah, this question. A typical solid fertilizer for use with household plants and blah 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 blah. The ratio is there between nitrogen, phosphorus, and potassium per 100 gram fertilizer. The recommended usage of fertilizer is 14 gram of fertilizer per 5 decimeter cube of water. Now this question says, what is the concentration of nitrogen atoms in this solution? So 100 gram fertilizer has how much nitrogen? You can clearly see that it has, nitrogen was the first one, 15. So it has 15 gram nitrogen. The question is concerned with 14 grams. So 14 gram fertilizer would have how much? So we can clearly solve it. Times 14, so that is 2.1 gram nitrogen. The question wants the concentration, right? Concentration is equals to moles divided by volume. Concentration is equals to 2.1 divided by 14 because that is the moles, mass over mR, and then volume is 5 decimeter cube. So that is over here. It's going to be divided by 14 divided by 5, 0.03. So 0.03 is the right answer. I don't want to overwhelm you guys, so I am pausing here. We have more MCQ questions. I would really recommend you guys coming back so we can solve more questions. Stay tuned, guys. Thanks.